We're going to go ahead and start by graphing quadratic functions where our a is positive. Um, the first thing we want to do is make sure that when we look at our function, we start to label. So I want us to be able to recognize that a is 2, b is 4, and c is positive 1. This quadratic function is already written in standard form. By now, we should already understand that our c is our y-intercept. The A also determines whether our parabola goes up, where your arrows are facing up, or if it's going downward, where your arrows are facing down. Now, because this is a positive 2 as our A, we know that the shape of our graph is going to be a U shape going up, where the arrows are going up to positive infinity on the y-axis. So step 1 is going to be to find the axis of symmetry. As you can see in parentheses, I put label each part of your function. That just means to know your A, your B, and your C. This is going to make it easier for you to substitute and find your X. The X that we are finding is the axis of symmetry, which is also the X for our vertex. So I'm going to start by zooming in. Now that we have our function labeled, it's going to be easier for us to substitute our values. So I'm going to go ahead and start by putting a negative in our numerator. We're going to open a parentheses for our B. We're going to write our 2 and then open a parentheses again for our A. You want to make sure that the minus in your numerator is there. If your B is negative, this is going to make a big difference. So you need to make sure that you're opening a parentheses for your B and you're opening a parentheses for your A. So in this case, our B is 4. And our A is positive 2. We're going to go ahead and solve. That's going to give us negative 4 over positive 4, which gives us negative 1. So the axis of symmetry is negative 1. Again, this is going to also be the X value in our vertex. So if you want to go ahead and start by drawing your axis of symmetry, you're going to make sure that you have a dotted line where X equals negative 1. Why? Because we just solved for X. This, again, is the axis of symmetry. So that means that when we start to draw our parabola, this is going to separate and cut our graph down the center. Now, once you have your X value, you're going to go ahead and substitute that into your function wherever you see X. So the input is going to actually be negative 1. And the output is going to be our y's, which is what we're going to find out. That is the same y that we're going to have for our vertex. So into our function, which we already have, this is it right here. We're going to have 2. I'm going to open a parentheses for my x to the second plus 4. Open my parentheses because we're going to have x again plus 1. Where did I get this from? Again, this is our function. This is the function that was given to us. So wherever we see x, we're going to substitute negative 1. I want to make sure that we know where this negative 1 is coming from. I'm going to use orange to substitute negative 1, negative 1. And now we're going to go ahead and solve by following the order of operations. I'm going to put h of x here so that we can remember that the value that we're looking for right now is our y, which is our output. So we're going to start with negative 1 to the second power. That's going to give us 1, 2 times 1. Then we have 4 times negative 1. I'm going to go ahead and just put minus 4 and then plus 1. 2 times 1 is 2, minus 4, plus 1. And we're just going to solve. So 2 minus 4, that's going to give us negative 2. Negative 2 plus 1, that's going to give us negative 1. So it just so happens that our y value is also negative 1. So the actual vertex for our function is negative 1, comma, negative 1. So that is exactly where we are going to put our dot negative, oh, not here, negative 1 and then down negative 1. Okay, so step 1 is find the axis of symmetry. This is the same x that is part of your vertex. We got negative 1. Once you have your axis of symmetry, you're going to substitute that x value into your function. The input that you place where you see X is going to produce your output as you start to follow your order of operations. When we substituted -1, we had -1 to the second power, which is +1. +4 times -1, that gave us -4. Bring down your 1. Go ahead and start solving. 2 times 1 is 2. 2 minus 4 is -2 plus 1. That's going to give us -1. Now, step number 3 says use the y-intercept to find another point. Okay. In our last lesson or the last 2 chapters, we learned that our y-intercept is actually our c. So that means that our parabola is going to touch at 0, 1. Okay. Where do you see +1 on your y-axis? That is going to be right over here. This is +1. Okay. So C, this is the y-intercept. The y-intercept, again, is where x is 0. This is what we have. So your first point is going to be at 0, 1. Now, in order for us to actually have a parabola shape or a U shape, we need to have a point to the right and then a point to the left of your vertex. So how are we going to get this point? Down in step number 3, where it says remember symmetry, I want us to look at our graph. I'm going to zoom this in, and we're going to count how far our first point is from our axis of symmetry. So if we look carefully right here, from the axis of symmetry, the distance is 1 point. So in order for us to have symmetry, we're going to go the same amount of units, but to the opposite direction. So again, if we're looking at our y-intercept and we count how far that is from the axis of symmetry, that's 1 unit. So to make sure that we're matching that from the axis of symmetry, we're also going to hop over 1 unit. So the next point that we're going to have is going to be -2, comma, +1. Okay. From there, you're going to go ahead and connect your points. I'm just going to give it a little rough draft. This is pretty much what our parabola is going to look like. Now, if you want to test your point, okay, if you want to test your point, you can always look at the x value of the point that you have. This point in our parabola is -2, comma, +1. So how can I check? I can always substitute -2 into my function, and my output should actually be +1. So what would that look like? You're going to have 2, -2 to the second, plus 4 times -2 plus 1. And then you're going to go ahead and solve. This is going to ensure that you actually pick the correct point. So if we were to do that, this is going to give us +4. This is going to give us -8 plus 1. When we multiply here, we get 8 minus 8 plus 1, which is going to give us +1. So that ordered pair was actually -2, comma, 1. So that shows us that the point that we picked is actually symmetrical to the y-intercept, and it also goes perfect with our